stack of the remote thread you're going to create, and then one for the actual shellcode. You then call VM write to copy in the shellcode, you set it to be executable, and then you simply call thread create running, which is synonymous to create remote thread on Windows, and will start a new thread at your shellcode. So runtime code injection is nice because it allows you to target arbitrary process, but it does have some downsides. So first, you need an external monitoring component that's already running. So say you want to inject into the user's browser. You have to have some piece of malware that's already running on the system that's waiting for the browser and then triggers the injection. So this means more things that you can detect. It's also a touch complex, using shellcode, stuff like that. And finally, it's easy, in my opinion, to detect. Process A shouldn't generally be creating remote threads in process B. So let's look at load time injection. So we can use dilib hijacking to gain load time code execution whenever a vulnerable application starts by simply dropping a malicious dilib. So let's look at Xcode. I thought Xcode, which is Apple's IDE, would make an attractive target for malware. Malware could use this as an autonomous propagation vector, right? If it's chilling in Xcode and it sees the developer building a release version of the binary to ship out, the malware could just inject some malicious code at the source code or compiler level. That's a really super stealthy way for it to automatically propagate. Turns out that Xcode is vulnerable to a dilib hijack attack, so we can simply drop a malicious dilib to the file system, and now every time Xcode starts, our malicious dilib will get automatically loaded and executed by the loader within the context of Xcode. Now, you can have the most sophisticated malware in the world, but if it gets caught, it's game over. It's like the worst thing that can happen for the malware. So I want to talk about bypassing some security mechanisms that either detect or prevent malware. I'm going to talk about how we can bypass them. So current OSX malware is detected or blocked by these security mechanisms. I'm going to start by talking about Apple's. I think this is really lame. Apple loves this though. They love to tout, hey, our security mechanisms are awesome, they'll protect you. But I'll show you we can bypass all of them. So I think this exudes a false sense of security. So let's start with talking about Gatekeeper. Remember I mentioned that pretty much a lot of software is downloaded over HTTP. They all count on Gatekeeper to verify that the software has not been modified in transit, that the digital signature is still valid. Gatekeeper also blocks unsigned downloads, so it does protect the dumb user who's going to think the Flash installer is really Flash installer. So how does Gatekeeper work? Well, basically, anytime you download something from the internet, it gets tagged with this quarantine attribute. And then when the application that was downloaded is run, either automatically by the operating system or the user double clicks it, Gatekeeper kind of jumps in the way and says, hey, wait a minute, this was downloaded, I got to verify it and make sure that it's signed, it hasn't been modified in transit. And it actually does a decent job. Turns out, though, that Gatekeeper only verifies the downloaded application. It does not verify external content, which is normally not a problem unless the application that was downloaded has an external relative reference to some content that it loads. So what we can do to bypass Gatekeeper is, well, 3 easy steps. First, we find an Apple-signed or Mac App Store app that contains an external relative reference to a hijackable dilib. Then we create a DMG or a zip file image, or we could also inject this into a legitimate software download if we have network level access. And then we kind of laugh at Apple. So this is how it all kind of works. Again, we have Gatekeeper set to the Mac setting, saying only allow code from the Mac App Store. We then build this malicious DMG file. We control the icon, the name, the background, so we can make it look however we want. So hidden behind this is an Apple-signed application that has an external reference to some code that we can actually load. So if the user double-clicks this, they will still get a standard pop-up because the content was downloaded from the internet. Now this is a generic pop-up that will occur for any software you download from the internet. So even if it was a signed version of, say, Google Chrome, you would get the same pop-up. Note though, it's saying only allow code from the Mac App Store. We have unsigned malicious dilibs in here that should not get loaded and executed. But because of this vulnerability, they do. So I reported to Apple, they patched it, but as we'll see at the end, we can still get around Apple's patch as well. So I want to talk about Xprotect. Xprotect is Apple's built-in antivirus product.